Alright, sorry for the late start tonight, everyone. We're just getting things rolling. Welcome to another episode of Dan Does Data Tonight. We're going to continue our text generation study, and what I had intended to do was take some text not from William Shakespeare, but from Dr. Seuss, and try to learn from that, thinking, I'll learn from kids' books, and Dr. Seuss is particularly unique in that regard, so why not? But I was having a hard time finding a Dr. Seuss corpus online of like all of them. Like you can get some of them, certain stories, but like you need a lot of data to make this all work well. So we might not do that explicitly, but I would love to come back to that idea. Instead, what I want to do is I want to describe an alternative. We're going to do something similar, but not totally different. We're going to stick with our Shakespearean text just because that's what we got. It's already set up, ready to go. I want to build a simple network. So we'll take some Shakespeare, a little bit. We'll build a small, simple network, and it'll make our predictions, whatever. Then I want to use transfer learning to get the small, simple network to kickstart a bigger network, maybe learning something more complicated. So that might mean more layers, it might mean more nodes on this layer, more nodes on all the layers, something like that, and sort of continue this process. And so gradually get more and more complex, using hopefully more and more complex inputs. That was the idea. I was going to grab the children's input. The idea being that when you try to learn how to read or write, you start with simple text first, and you work your way towards more complex text. So sort of a natural progression that maybe it will be easy for the model to learn simple things, and then you can gradually add on more complex features to the model. So that's the idea anyway. Making this all work in Keras might not be trivial, and making this all work at all might not be trivial. Let's load in our data file for the moment. Let's color adventurous. For those who only watch the videos and don't read the blog posts, the model generated actually did pretty well. I was impressed. Oh yeah, since I updated my Theano, it gives all kinds of wacky, it gives errors because I don't have cuDNN. So I still get to use CUDA, but I don't get to use the special libraries with it. Yeah, cannot use cuDNN in context not in device not supported because my device is too old. But it will use my actual device here. There we go. So I'm just reading in all my data, turning it into the format that I want. And I think I don't want a model that complicated, I just want that. Now I want to model load weights. I haven't specified model. Okay. So let's start with this model, I guess. Just to demonstrate how the previous model worked, I guess. Just to show people that it did something decent, not crazy. So if you pick a particular point in the model and you tell it, hey, generate some text here. So it gets 40 characters from the actual text to start on. So you pick a position and then it will actually generate that text. And I'm not going into a lot of details because this is just to show where we sort of left off last time. That takes us good old time. It's got to compile the model the first time, of course. So let's start on something simple here. New simple model. New simple model. Yeah, there we go. So it started with marry me or else, and the strong of the head of the love of such a purse that not the cent in a per pound beat. But I have thy soul comes for the book. See, it sounds like Shakespeare. It's got that feel. That's by the nature of the model we've constructed, it has that feel. All right. So that's where we got last week. But let's let's sort of step back and try to build our way toward a simple model. So what I want to do is I would actually like to start with one guy. Oh gosh, I don't remember what all these things are. 48? That's how many embedding, that's the embedding dimension, okay. That explains a lot. Max line. I want to simplify this a little bit. 20. 48, 64. I'm going to keep this stuff the same just for giggles for now. Because I'd like to compare the model I slowly build up to a model that starts simple. Yeah, I like that idea. I like that idea a lot. So we could add more layers at a time and sort of try transfer learning that way. Or we could start with fewer nodes and then add more nodes and copy over the previously learned weights. I want to try it layer by layer first. See how that works. Okay, so that's a simple model. And to train, I've already got data set up the way I want it. You do something like this. And this is Bardic weights. Simple. There we go. So let's initiate the simple model. I don't actually want to spend all the time figuring out how to train it today. But let's just make sure that process actually runs. Yeah, there we go. But got array with shape. Oh, right. I should change. Max length should still be 40. No reason to drive myself crazy. Alright, let's try this again. I got array with shape such and such, such and such. Did I not rerun my data? What am I passing in? X and Y. X, Y. I feel like I mucked around with this the other day and I didn't really mean to do that. Oh boy, oh boy, oh boy. I clearly screw around with the data here. This is a problem when you change one part but not all the other parts. Right, I keep the dense encoding because the embedding takes care of that. X.shape. But it's expecting model.summary. It's like, this is the thing I did not want to really worry about much. 40, 48 is the output shape. Is there a model dot like input shape? Wow, there is. I did not think that was actually going to be there. None, 40. I feel like that's the correct thing. That's the expected shape, man. Why you gotta be cramping my style? Expected activation 3 to have 3 dimensions, but got array with shape. Oh. I know what went wrong. I know what went wrong. I'm returning sequences here. That's why it's all mucked up. That's what you need to pass on to the next, to do another recurrent layer. That's all. No biggie. Easy to fix. Easy fix. Alright, let's see how this works. Should be fine. Again, I'm not going to actually let it train for a long time. I just want to verify that it does something. What it actually does, I'm not too concerned. Because I'm going to say model.getWeights. This is going to be W, let me think about this. W1, B1, and WF, BF. So the first layer, oh shoot, and there's the embedding. E, comma W1, B1, WF, BF. I think that's approximately correct. This model's taking forever. Come on. I just need you to compile and do something. It does not have to be complicated. I don't know why it's making its life so complicated. Whatever. We're going to get the model. I just want to pull those weights out, and then I want to specify another model. So, call these model 2. There we go. And what we're going to do, return sequences. That's true. Okay, kill that. That's doing something, that's fine. Model.get weights. What do I get back? It's a list, of course. 6. What are the 6 things? So now we have to play the game of what are the 6 things that I get? M0.shape. So this should be the embedding. Yes, from 34 to 48. So M of 0, comma 0. The first, if you pass in an A, I think, whatever the first character in the list is, you get this vector out. Okay, that makes sense. What is 1.shape? Is the first layer? 48, comma 256. That I'm not sure about. This should be a bias term, 256, 64, comma 256. M, comma 3? That's a bias term. 4. That's a dense term. 5. Alright. So from the embedding to the... Hang on. We'll study this model again here. You've got an input of a 34 model. Let's do this. Just simplify my life a little bit. You've got a 1 number going in originally. Right? Yeah. Originally. That number gets mapped to 48 things. Those 48 things should get pumped into your LSTM. So why am I computing, what is this? What is M1.shape? This thing? Output shape. 48 times 40. 1920. No? 34 times 48. Yes, okay, so that's the embedding. And I use the embedding to go into the LSTM and out pop. Oh, there's like an interior part of the layer, an interior activation, and an other activation. Okay. So that's what some of this business is about. And this is some kind of bias term. So really what I need to do is ask, LSTM, how do I actually, which weights go where, is the question. Kernel regularizer, yada yada yada. Wait. Initializer for the recurrent regularizer, bias. So there's kernel, recurrent, and bias. And I believe kernel, recurrent, and bias. They occur in that order. Used for the linear transformation of the inputs. I didn't know that happened. Used for linear transformation of the recurrent state. Okay. So this is on my inputs. So that's at 48, 256. This is on the recurrent stuff. That's at 64, 256. And then just the bias. Okay. I need to rethink how I want to call this then. And it's always recurrent, no. Kernel, recurrent, bias. Kernel, recurrent, bias. Kernel, recurrent, bias. Okay. This should be correct. So we got this embedding, these kernel weights, these other weights. Okay, good. Because now we're going to add another one of these goobers. We're going to add another layer here. All I want to do is set some of the weights. And that's the transfer learning aspect of this. Set the weights of the model. Should be a list. Numpy with shapes and types matching the output of model log gets weights. Okay, so let me just say my old weights, model2.get weights, just to get the shape correct, is this. And then length of WW should be 6 plus 3 more, 9, I believe. Yeah, alright, good. We're just going to say WW0, well, WW of the first 4 equals E, comma K1, comma R1, comma B1. I think I can do this. Can I do that? There we go. WW0 equals E. Yes. Well. Alright, that's good. And now we say model2.set weights of WW. And now we've instigated some transfer learning. Huzzah! And so then you would do a little bit more training with your more complex model. Probably, hopefully the goal is not as much training. So I'm going to cut this 5 or something. I don't know. Whatever. And then you would run it again. Let's see what happens. I need to change this to model 2. There we go. More. We'll call it mid. We'll call it medium. Medium. There we go. So the idea is you would train a little bit more, start to specify. If someone is familiar with if this kind of model construction process and model training process is already done somewhere, I'd love to hear about that. I haven't done any research on that particular aspect of it. I just thought that this would be a good way to do this since I couldn't find the Dr. Seuss model. And in fact, I would like to not train this much anyway on this simple model. Num blocks. Do I not want to? Yeah, let's actually only train on like the first half of the number of blocks or whatever. Here, we'll train on like the first 8, I don't know. Okay, but now that we understand how this works, we can actually do this process again with a slightly more complex model. Full model, so to speak. So what I'm going to do now at this point is WW. Hang on. Let's call this WW2. So we get the old weights. These all become 3s. There we go. And we're just going to add one more of those layers. That's all. I think we should be okay as far as the return sequences business goes. I'm obviously going to interrupt that. I don't have time for that. Ain't nobody got time for that. We'll specify this. And we will specify this. But now, instead of setting each part individually, instead of the first 4, I want the first plus 3 more 7. WW2. Right? And just to be paranoid, we'll grab the interior. We compiled. Get those weights. Do that. And we'll reset the new weights here. Using WW, yeah. Dunk. Oh, didn't like that. Nope, didn't like that at all. Alright, let's take a look here. Should be 12. Yeah. Alright, let's take a look at all the weights. or WW in WW. A lot of W's going on. And let's take a look at model 2s. So where 34, 48, 48, 50, 64, 256, 256, 64, 256, 64, 256, 256, 64, 60, 34. So I just want these first 7, yeah. That's all I want. Need to compile model 3, not 2. Oh my gosh, you're right. Simple problems. As usual. Thank you so much. Ding, there we go. Do this again. No, still doesn't like. Wrong number of dimensions. Expected 2, we got 1. Still, it's not happy about that. So WW is model 3. 64, 256, 256, 64, 256, 64, 256, 256. Everything up through this 256 should be fine. Oh, I don't want everything from WW2. That's the problem. I only want the first 7, right? Yeah, that's the problem. Right, because the end weights are sort of fixed. Grab that, do this. Boom, look at that. And then you can train that a little bit more as well. Maybe you train that more fully, maybe you don't. In fact, I'm going to say you just refine a little bit, but on all the data now. There we go. Let's make sure I update these to model 3. Now I kind of feel like I should have a function to do this for me. There we go. Doink. And that should actually work then. And so what we've done is built a simple model here, LSTM, to generate some text. Told it to train for a little while, get something simple, and then use those trained weights to go into a new model that's a little bigger, can learn a little bit more. And you could freeze the weights right there and just compute new things, but I decided to let them also change. It might be interesting to let all the weights change, but use different learning rates per layer, so that these ones that they've seen a lot of stuff, the learning rate might be a little smaller. You don't want to tweak them as much. And then as you go further on, we built an even bigger model where I just got these 3 stacks. So that's sort of the add more layers approach. Since we have a little bit of time, stupid GIMP. I do not understand why GIMP, fine, go away GIMP. Why those windows don't go away. That's very irritating. So, oh no. This isn't medium, this isn't medium! Also, I forgot this. Oh, that's interesting. Input dimension mismatch. Well, that's fascinating. Why is that a problem? Input 1, and C started 0 as shape 1, but the output size and axis is 34. That's curious. Model 3.summary. What went wrong here? No, it all looks hunky-dory to me. Embedding 6, yeah. Those are 40 long, yeah. Wait, yeah, that makes sense. Because x of 0 is going to be the first 40 characters. So what was I complaining about then? I didn't change anything in the input side of the model, did I? No, of course not. That'd be silly. Embedding length chars, 48 input length max chars. None of this changed. All I added was another one of these goobers. That's the only difference here. So I'm curious. I did recompile this model. Tell you what, let's rerun the whole model there. Just to be paranoid, let's do all this. There we go. Do we not actually have that many blocks? Is that what the problem is? Blocks. No, 10. I have 10 blocks. That's not the problem. It's got no business throwing these errors. Alright, well that tries to compile. We will look at an alternative model construction. So this is sort of one construction, and there's nothing wrong with this. Another idea, and maybe you can combine these ideas. Select none. Is to, instead of making your model deeper, use transfer learning to make it wider. And sometimes this is the appropriate thing to do. So I have a model, maybe I've got, on the left here, maybe I've got these 64 nodes. And I've trained some interesting things in those. And then I say, okay, I'm ready to train a little bit more. So I'll have the same basic model. Oh my gosh, this is so illegible. This mouse paint. Yeah, see, now it's running fine. It's baloney. And maybe you want 128 nodes. But we'll copy the weights for the first 64 nodes, both on the input side and on the output side. I guess only on the output side. That's the only thing that makes sense. Wait a minute. Brain. Gotta think about this. So I've got 48 numbers coming in, and I need to compute 128 numbers going down and 128 numbers going east. Going to the next time step, because it's this recurrent thing. Yeah, trying to do this with recurrence without first doing it for dense layers was perhaps a mistake. But I wanted to try it with the text generation to see how that would go. So today we're not going to be able to see like how it actually works, of course. But that'll be something interesting to take a look at. Anyway, so it was 48 going to 64 things. It was 48 to 256 essentially, to cover the recurrent output and the dense output. And now it's 48 to 128. So yeah, on the input side and the output side. Because in the output, I'll be computing these 64 plus 64 things, where the first of them will be the same as these guys. And when you start training. So you might as well copy those weights over. Alright, you don't need to be training while I'm doing stuff. Alternate approach, wider net. So let's just grab our most complex model, because why not? And now I will go with model 4. And model 4 will have 128 things on this layer. That's going to be the only difference I'll have at the moment. And I will update the compile line as I did before. I'll not forget about that this time. So that's model 4. And it's going to inherit from model 3 as much as it can. And so if we take a look at model 4.getWeights, and I look at the shape of those things, dot shape, wwin, it's that versus model 3. The only differences are here, 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 and here, right? Yeah. You should have the same number of layers though. So the embedding's the same, That's good. We should replace, this is where I think it's going to be the first quarter and the third quarter of these, I think. I'm not 100% sure on that, actually. Let me think about this. It's the kernel, and then it's the... Oh boy. The kernel and then the recurrent weights. So these 64 things are coming from the previous time step, and we're computing 256 things. Why are we computing 256 things? We're passing 64 down and 64 forward. We also have two types of state, is that correct? LSTM. Alright, fine. We'll just go here. I'm just looking for the stupid picture on LSTM diagram. I think they do have two kinds of state on the inside. Oh my goodness. Understanding. Ah, here we go. Yeah. This might be good. Recurrent neural network. Is this my LSTM? Standard RNA. Repeating RNA. Okay. So, walk through all the LSTM. The question is the H of T. This is passed to the next time step. I've got two components passed to that, and I've got the H of T, my actual hidden state. So I got to pass 64 things on, and 64 things times 2 forward, I guess. And so what other such and such would I need? Step-by-step walkthrough. I guess there's internal computations, is what it really is. So I still think it's going to be all of the hidden stuff. But that's only 64 things. Curses. Oh, but now it's under 28 things. Okay, so I still believe that. Although I don't know that that's how it's actually going to be implemented. But ww3 equals model 3.getWeights. Let's do it anyway for now. So all kinds of transfer learning today is apparently the moral of the story. ww4 model 4.getWeights. There we go. So it's not going to be so trivial now. So I want to match transfer first layer weights, layer 1 weights, including embedding and others. Right. It's got the same length. So what I need to do, let's get 2 copies of the weights, just for giggles. And then I'm going to muck around, I'm going to borrow pieces of one of them. So what I want to do is no. Let me start with a copy of the third model's weights. So I'm going to start with model 3, and then I'm going to just fix those handful of weights where the layer sizes have changed. That's all. So WW position 1, I need to set equal to WW3. No, it's already there. Hang on. WW1 I need to set equal to WW4 of 1. And in fact, I want 1, 2, 3, 4. 1 through 4, I believe. Let's do that here. Okay, we'll do that. Do that. So now it should have the right shape. Shape for WW in WW. Yeah, it's got the right shape. I just need to update those actual weight values. So WW of 1 is going to equal WW3 of 1, except WW of 1 dot shape and WW3 of 1, the recurrent part, no, excuse me, the kernel part of that layer. So what I want is not the first half. I want the first quarter and the third quarter. Blah. So everything up to 128, right? No. Everything, comma 128 equals everything. And then from 256 to 384, and this is 128, and this is 128 to the end. See if that works. Nope, didn't like that. Ah. All the rows, only those columns. That's the difference. There we go. And so it's this, I need to do this for the 3 types of that layer. So that was the kernel. Now for the recurrent part. Let me see. That, this is where we're gonna get burned now. 3.2 dot shape. So the first half of these in the same first third quarter business over there. So 64 there, 64 there. I think that's correct. And then the bias terms should be a little easier. And WW3. 3 dot shape. And will that be, I think that'll be the same business. Except this, oh boy, what happened here? I mucked something up, didn't I? Ah, here we go. Much better. Whew. There we go. First third, second third. Sorry, first quarter, third quarter. Oh, man. Misery. And then you would say model 4.setWeights WW. Boom, look at that. Now you can train some more. Now we're expanding the model. And, you know, let's cut down the number of epochs here that we will pretend to train. But let's make sure we update the actual model that we're training. Okay. Get that going. That should work just fine. If he yells at us, well, we'll figure it out. And so that's what we activated here. We did transfer learning with a smaller model, starting with 64 nodes in our LSTM, because it's all the recurrent stuff. It's hard to keep in your head and make it work right. With a dense neural network, even a convolutional neural network, it would be much easier to keep straight. But you know, why not do the most complicated thing first? And we trained that for a bit and use that to kickstart the training process of a more proper network. Now, of course, because text generation takes forever to train, one might not want to do this. One might not want to try to do this live, because we won't actually get to see the results for a while. I'll have to let this train overnight or something. And good gravy, look at how big this is. Look at that. Jeez. It's like taking an hour to train one epic. Ugh. Misery. One epic of one block. Yeah. So 10 hours for one pass through all the data in this ginormous model. Which, maybe isn't really that terrible because I've got super old hardware and you might let it train for a long time. I'm certainly not going to let it train all that long. But that's how that could work. Alright, I think that's all I want to attempt tonight. If you have a data set of all the Dr. Seuss texts or like a children's literature, I would love to see that. I saw there was some corpuses online maybe, but I didn't want to download them and have to fight through those on the stream since we've sort of already done that, getting Shakespeare stuff ready. So that's all we got for tonight. I hope everybody learned something. I fought a little bit with this. I'm surprised the transfer learning part worked. That's one of the most powerful parts of machine learning and neural networks. You can take stuff that your model's already learned and relatively easily apply it to another problem or even just a more complex version of the problem. And I'm curious how this kind of iterative improvement process will do. All right, so thank you very much. Don't forget, stay safe in the data mines. Take care.